Hello everyone. I would like to thank the committee to accept my paper. The work is done by a BTech student. His name is Rahul, and I'm going to present his work. The work is Graphene-Based Surface Plasmon Resonance Sensor for Milk Adulteration, and I'm Sajal. So the presentation will go like this. So first of all, I would like to point this: what is the SPR sensing? Basically, SPR is the optical based principle through which we do the sensing for the reflective index change in the analyte, whatever analyte we are taking, and to make our sensor more and more selective, we need to use different layers, basically known the BRE layer in terms of the sensor field. So, as the other sensor, in optical sensor, again, we are going to use three stages. First is your BRE layer, basically where the analyte is going to sit and it will interact with the sensor. Then our transducer. So transducer is the area where we is the field where we are converting the energy from one to another part. So here the transducer is our optical sensor, and then we can go for the signal processing. So in the case of SPR sensor, it works on the principle of surface plasmon resonance. That is the full form of SPR. So we need to generate the surface plasmon positons so that the light can interact with the analyte and it can sense the change in the analyte. So in this case, we need to incident the light that can be of different wavelength, but in normal case in SPR we use 632 nanometer wavelength, and that laser light will be incidented over the prism, as you can see in the first figure. So we are using a glass prism. This is the most basic example of SPR sensing. So when light incident with a angle, the photon will be interacted with the electron in the on the surface. So we need to make arrangement of metal and dielectric interface, and when the electrons are excited, non-radiative surface plasmons are generated, and it is like a cloud of the plasmons, and then this energy will be interacted with the analyte as the evanescent wave, and that wave runs parallelly in this direction and it decay eventually. So we need to put our analyte at the surface such that the evanescent wave which is generating will interact more and more with the analyte to see the change in the resonance condition. So the basic thing is how resonance done. So when the momentum of the incident light is coincide with the momentum of the pluralitons, in that case resonance occur, and at the resonance condition we got the minimum reflection, maximum reflection, or you can say minimum intensity reflected back. So that is the basic of the SPR sensing. In the case of SPR sensing, we can use two different type of setup. So first was this, and in the second setup, we need to maintain a small distance between the prism and the metal. That setup is somewhat typical to maintain. So normally we go with the Kretschmann setup, which is seen here. So for this work, we try to use the basic SPR setup, and we try to accommodate the nanomaterial film that we took graphene for this work to enhance the sensitivity of our work. So till now, when we study the milk adulteration properly, we normally see that we have various chemical sensors. I'm not saying that sensors are not available, but most of the sensors are work on the electrochemical or electronic based sensor, and sometimes in chemical sensor we need to have a larger setup and it takes time, or we need to work with the chemicals which is not viable for normally layman person who wants to check the adulteration in their milk. So that is why in the case of optical SPR sensor, if we can have a small prototype of device, they don't have to work with the chemical. Just by seeing the reflected light, they can see. So this is a theoretical study. We did an analytical study by using the transform matrix method, and in this method we need to break our whole system into small pieces, and then we do the analytical study. For this is the sensor design which we choose. First is the BK7 prism we use to couple the light which we are incidenting with the sensor, and then gold, silver, graphene layer, and the sensing medium. So in normal conventional SPR sensor, we use either gold or silver film, that is known as the conventional sensors. But here we use the bimetallic approach. However, when we see the result, it is like in comparison with the single layer SPR sensor, we have a we have a sensitivity which is some point lower than the single layer SPR sensor. But with that, if we are going for the bimetallic approach, we are having more viability, because you can see that when we are using only silver, in that case the oxidation of that layer is much easier than the gold. So if we can make a combination and we can secure the silver film using the graphene layer, we can reduce the chances of the oxidation, because we are putting the analyte directly over the sensor surface. So for the initial study, we first take the single layer sensors, and from the single layer sensor we get that maximum shift of 1.88 degree angle is shifting. That is why we shift to the bimetallic approach for the better detection accuracy as well as for the stability of our sensor. And from table 2 you can see that the shift in the angle is lesser than the single layer, but when we compare the detection accuracy, that was higher. So from this we took the third one, where we are using the prism with the 30 nanometer thin gold layer and 20 nanometer thin silver layer, with the shift in the angle of 1.372. That is the maximum shift we got from the bimetallic sensor. And then these results we got for 3 different combinations, which I already showed you. So you can see that these all are the resonance spectrum, reflection spectrum we are getting from our sensor, and we require these spectrum should be as narrow as possible. But as we are changing the thickness of different layers, those spectrum are getting narrower or broader. So if the spectrum is more broader, in that case, it is not possible for us to detect the shift in the angle. And the shift in the angle is the main part of the sensing in this case. So we want the narrow spectrum, or you can say the lesser and lesser FWHM. So to achieve that, we shifted, we put the graphene layer over the bimetallic, and we got this type of spectrum. From this spectrum, it is seen that from the previous work, the reflective index change of the analyte is 1.325 to 1.335. That is 0.01 RIU we are changing. However, in the case of bimetallic approach with graphene, we are changing our sensing reflective index from 1.345 to 1.348, means 0.003 RIU we are changing, and we are getting a sufficient shift of 0.82. And with the 0.01 change in the RIU, we were getting the shift in the angle of 2 degrees, so which is higher than the single layer SPR or conventional SPR sensor, as well as the bimetallic SPR sensor. So the thing is, as soon as we are using the different qualities of the nanomaterials, we can enhance the sensitivity of our sensor, and we can make our sensor more and more selective also. However, we didn't work on the selectivity at this time, but we can make our sensor very selective. So from this study, it is seen that SPR sensor are a very good, are very easy, not good, easy solution for different sensing techniques where we need to use with the chemicals and all, and we do not everyone is ready and not everyone is capable of working with the chemicals. So we can give this idea as the prototype for the milk adulteration sensing. These are the references. Thank you.